أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Dear students of class 11th, today we will study the application of concept of M plus. We have situations where we see that a cricket player lowers his hands while catching a ball. This is because he wants to increase the time to stop the ball. Hence, by increasing the increasing the time, he reduces the retarding force and he saves himself from the injury. And we see that a person falls on the hard floor and gets injured. That is it. There is retarding force is large because change in momentum is large. Change in momentum is large. So he gets injured while on a heap of sand or a wood dust. We see that he does not get injured. That is why there the time sand yields and the time of interaction increases and this decreases the retarding force and the person does not get injured. Automobiles, we see they are provided with shockers. These shockers, when they move on these automobiles move on a rough road, they receive jerks and shockers increase the time of jerk, and that then the force action per passenger is reduced. It is easier. We see that it is easier to catch a small tennis ball than a cricket ball. The reason is simple that in a cricket ball, if they have same interval of time, the heavier ball will have large movement, and this tennis ball will have smaller momentum, and stopping the cricket ball will need a large force. So it is difficult to catch or stop a heavy ball. Now we see that glasswares and chandelier, they are packed in straw. So while during their transportation, when they get jerks, their time between the increase between the jerk and these glassware or chandelier, that is reduced. That increases the time of interaction is increased and the force of return force is decreased and so are less likely to be damaged. Here are some numericals on M plus. First we know the formula. We have J M plus is equal to force into time, or it is also equal to change in momentum, that is mv minus mu, and also J is equal to integration of t1 to t2 from f into dt, and that will be given by the area of under the force time graph. Also in the plane xy, the impulse G can be written as J is equal to jxi cap plus jy j cap, and jx is equal to p fx minus p ix, and jy is equal to p jy minus p I y. The magnitude of J is equal to Jx square root of Jx square plus Jy square. And direction of J is given tan theta is equal to Jy by Gx, or theta is equal to tan over J. Now we consider a ball of mass 200 grams traveling with a speed of 15 meters per second on negative x-axis. It is deflected by a bat at an angle 30 degree. If the speed of roll of the deflection is 10 meter, we find the impulse of the ball. You see the figure. The velocity is vix along negative x. Final velocity is along the blue line VF and angle between them. So mass of ball is 200. That's 200 by 1000. That's 1 by 5 kg. Ux is equal to minus 15. Uy is 0, and V is 10 meter per second. So Vx final component of velocity will be V cos theta. V cos theta, that is 10 cos 30, that is 10 into root 3 by 2, that is 5 root 3, and Vy is equal to V cos sin theta, vertical component, that is 10 into 1 by 2 into 5, 1 by 2, that is 5 meter per second. Now impulse will be changed in momentum along x-axis. So that m into Vx minus Vy, so 1 by 5 into 5 root 3 minus 1 by minus 5. So that is 4.73. Now impulse along the y-axis, that is Jy is equal to m Vy minus Uy. 1 by 5, Vy is 5 minus 0, that is 1. So net impulse is root of jx square plus jy square. Jx square plus jy square. So that 4.3 whole square plus 1 square, and that is 4.83. 4.83. Then we have another example. The ball is moving with a moment of 15 kg meter per second. Strikes such a wall at an angle 30, as you see in the figure, and is reflected back with the same moment at the same angle. So we are given that initial momentum P is 15 along AO, and final moment is P dash is along OB, that is 15 kg, and theta is equal to 30. Now change in momentum along the horizontal. But change in momentum in the vertical is 0, because ball does not move vertically. So we will see. We will resolve the initial moment along vertical and horizontal. So it will be equal to both. P will be equal to P cos theta and P sin theta. So we will get P cos 30 plus P dash cos 30. So it is P cos 30 plus, so twice P cos theta. So twice into 15 into root 3 by 2, that is 15 root 3 kg. That will be the impulse. Another example, a ball moving with a momentum of 5 kg meter per second strikes a wall at an angle of 45 and is reflected to the same. So this question is similar to the one we have done, so that will be for you to try it.